We are going to continue from where we stopped in our last class. In our last class, we look at reduction formula for a function of nth power. We look at reduction formula for cos. Also, we look for also tan. And I told you that with that knowledge of sine, we can also get for cos. With the knowledge of tan, we can get for sec, cosec, and cot. But today, we want to continue still on reduction formula, but today we want to look at product of the nth power of the function. That is, if we have, let's say we have a function, let's call it im comma n to be equals to integral of, let's say, sine mx cos nx dx. We want to integrate this type of function. If we want to integrate this type of function, what we just need to do is it's not easy to integrate direct, but with the knowledge of reduction formula, then you can do that. Now, we are going to use integration by parts to derive the reduction formula. But the first thing you need to do is that you need to split one of these functions. You can split sine, you can split cos. It depends on which one is of your interest. But let me split one. If I split cos, I'm going to have my im, which is defined as, I can write it as integral of sine mx cos, I can write this as m minus 1 x cos x dx. Now, we now have three functions. Then I can also apply integration by parts to this function. Now, the one I split must be my u. If I'm splitting sine, my sine will be u. Since in this question I split cos, then my u will be cos. Then I can say my u equals cos m minus 1 x. Other function there will be your dv. Then I can say my dv equals sine mx cos x dx. I need to get my du and I need to get my v. Now if I get my du from here, I can say du equals, I'm going to differentiate this as function of function. I'm going to have, if I differentiate, so I'm going to have minus m minus 1. Since if I differentiate cos, I'm going to have minus. That's why I have the minus. If I differentiate cos, I'm going to have sine x. Then I have cos m minus 2 x dx. That is the derivative of cos m minus 1 x. Now, I also need to get my v. From here, to integrate this, it looks like another integration by part, but I won't make it to the integration by part. I know that if I differentiate sine, I'm going to get cos. Then I can write this as my dv equals sine n x cos. This cos I can write it as cos dx. I can write it as d of sine x, because I know if I differentiate sine x, I'm going to get cos x together. Then from our knowledge of integration, I want to integrate now. If I integrate, remember, if we want to integrate, let's say we have integral of x dx. Since the function I want to integrate is with respect to that same function, then I can say this function, the integral of this will just be what? X, and we add 1 to the power, it will be 2 divided by 2. It's the same method I'm going to apply to this. It is my dv will just be what? Sine m plus 1, because I'm integrating with respect to dx, not with x dx. Then x divided by, we divide by the low power, n plus 1. That is how to get my d. Then I can easily apply integration by part to the whole function, since I know my u, my v, du, and dv. Now if I apply the same formula, I'm going to have my I m comma n will be, the formula is uv. My uv is going to give me 1 divided by m plus 1 sine m plus 1 x cos m minus 1 x dx. That is uv minus v du. V du. Since in my du I have negative, that negative will multiply this thing in turn to plus. V du, I'm multiplying v and du. Then I have integral sine m plus 1 over m plus 1 x. Mind the u, I've brought out the minus. I still have m minus 1 sine x cos m minus 2 x dx. If I combine this, I will see that I have my I comma m comma n to be what? 1 over m plus 1 sine m plus 1 x cos m minus 1 x dx. Now I want to bring the whole constant out, which is plus n minus 1 divided by m plus 1 integral. Let me combine the function. I have sine m plus 1 multiplying another sine. Law of indices, this will turn to sine m plus 2 x cos m minus 2 x dx. This is what I'm going to have. Now, also recall. You can also recall that I can write sine m plus 2 x to be sine square x sine m plus sine x. Now, and I know that sine square x is the same as 1 minus sine square x. Instead of saying 1 minus what? Cos square x. Then if I substitute into this, I have my I, m comma n, will now be 1 over m plus 1 sine m plus 1 x cos m minus 1 x dx plus m minus 1 into m plus 1 integral. I'm going to substitute this now. I'm going to have sine mx sine power m to x cos, let me leave the cos, m minus 2x. Then I'm going to replace sine square x as what? 1 minus what? Cos square x, everything multiplied by dx. Then if I simplify, I see that my m comma n will be what? 1 over m plus 1 sine m plus 1 x cos m minus 1 x. There is no dx here, plus m minus 1 n minus 1 m plus 1. Now I want to split this. I want to open the bracket with that 1 minus cos square x. Then if I do that, I'm going to have integral. If I use it to open, this place will give me sine power m to x, sine x power m cos x power m minus 2x dx minus the same thing. Since I'm splitting, I have n minus 1 divided by m plus 1 integral. Now cos, this will give me integral of sine m s cos n dx. Yes, because cos power n minus 2 x multiplying by cos power 2 cos x power 2, the law of indices is going to turn to cos n. At the end of the day, if I simplify this, okay, before simplifying, take note. I can say let I m comma n minus 2 equals integral of sine x power n cos m minus 2 dx. Then I can substitute that into the function, and I'm going to be having, at the end of the day, if I put that, my solution will reduce to I m comma n equals, I have this to give me 1 over n plus 1 sine n plus 1 x cos n minus 1 x plus n minus 1 divided by n plus 1. I'm going to change all those one to I m comma n minus 2 minus, if I look at this other side, it's just like in the given function, that is n minus 1 divided by n plus 1. This is I m comma n. Then if I collect like term now, if I collect like term, I will see that take this I of m comma n to my left hand side. I will see that I'm going to have I m comma n plus n minus 1 divided by n plus 1 I m is equals to 1 over n plus 1 sine n plus 1 cos power n minus 1 plus n minus 1 divided by n plus 1 I m comma n minus 2. If I simplify this my left hand side, I can factorize out I m comma n. If I factorize out that, I'm going to have the fraction as 1 plus n minus 1 n plus 1 I m comma n to be equals to 1 over n plus 1 sine n plus 1 cos n minus 1 x plus n minus 1 divided by n plus 1 I m comma n minus 2. If I simplify this, the fraction here, I'm going to have all these things returned to n plus n divided by n plus 1 I m comma n equals 1 divided by n plus 1 sine n plus 1 cos power n minus 1 x plus n minus 1 divided by n plus 1 I m comma n minus 2. Now from here, I want to, because my plan is to get I m comma n, then I need to divide through by n plus n divided by n plus 1. And if I do that, I'm going to have my I m comma n will now be what? It's going to give me direct. It's going to give me 1 divided by n plus n, because n plus 1 will cancel n plus 1. Then I have sine n plus 1 cos power n minus 1 plus, this will also give me n plus 1 will cancel n plus 1. I'm also going to have n minus 1 divided by n plus n, everything multiplied by I m comma n minus 2. And this is the what? The reduction formula for the product of function. Just follow the step. It's very easy. Develop the step yourself. You see that it's very, very easy and simple. Now, at the beginning of the question, I told you I splitted cos. You can also split sine. If you split sine, your u will just be what? The sine power n minus 1 x. That is what your u will be, and your dv will be the other one. And that is just what you are asked to choose. Now let's see the application of this. Let's see how to apply this proved formula. Let's see. I'm going to solve one question, and I will advise you to do more, because you cannot understand all these things I'm doing without what? Practice. You need to practice more questions. You need to know how to derive it and also how to use the derived formula. Now let's look at example. Integrate, let's say integrate cos, let me sign with sine. Sine does not matter. Sine 2x cos 4x. We want to integrate this. Or we can say this. You can put the integral if you like. We want to integrate this. What you just need to do is write the proved formula, the reduction formula. Say that product of two function, and I know that for product of two function, my I, m comma n, that we just prove that is defined as 1 over m plus n sine power of m plus 1 cos power of n minus 1 x plus, don't cram it, very easy, just follow it. This is n minus 1 divided by m plus 1 multiplied by I m comma n minus 2. If I compare with this, then I can easily say what? My m is what? Is 2, and my n is what? Is 4. It means I can say the given function or integral is what? Is of 2, 4, which is the same as the integral of what? Sine power 2 of x cos power 4 of x dx. Now, if I substitute this into the given reduction formula, I will see that I have my 2, 4, I 2, 4 will be 1 over 2 plus 4 is 6. I have 6 sine 2 plus 1 is 3 x cos 4 minus 1 is also 3 x plus 4 minus 1 is what? Is 3 divided by 2 plus 1 is also 3. Then this will give me, it will go to just be 1. 3 divided by 3, that is 4 minus 1, which is 3 over 2 plus 1, which is 3. We have I, this is I, and my m is 2, 2. At the end of the day, my function will be I of 2, 4, just equals to 1 over 6 sine power 3 of x cos power 3 of x plus I 2, 2. What I need to do now is to express my I 2, 2. I'm going to do the same thing again by substituting into the formula. Then I said I 2, 2 will just be 1 over 2 plus 2 is 4 sine 3 plus 2 plus 1 is 3 cos 2 minus 1 is 1x plus, this is 2 minus 1 is 1 divided by 3 I 2, 0, because there is no n again. N will be n minus 2 will give me 2 minus 2, which is 0. Then at the end of the day, what I need to get now is to get I 2, 0, which simply means my n is now equals to 0, and this is defined as integral of sine 2x dx, because your cos, the power of your cos is now what? Is 0, since your n is now 0. Then I can easily to integrate this. I don't need to bother myself using that reduction formula, because I can express sine square x in a linear form. That is, this can be written as, if you apply trigonometry, you know that from this law, cos 2x is equals to cos square x minus sine square x. Then I want to get sine square x. I can say what? Cos 2x equals 1 minus 2 sine square x. If I change cos square x to 1 minus sine square x, then I will have this. Then make sine square x to be the subject, then my sine square x will now be equals to 1 over 2 into what? 1 minus cos 2x. Then if I substitute that, then I can easily see that what? My I 2, 0 is now equals integral. I'm going to replace sine square x as 1 over 2 into 1 minus what cos 2x dx, and it is easy to integrate, which my I2 comma is 0 now will not give me, I can bring out the 2, then I have integral. If I integrate x, and if I integrate 1, I have x minus, if I integrate cos 2x, I'm going to have sine 2x divided by 2 plus c, which is this. Then I'm going to substitute everything back to the given formula or the question, which is equals to, it means my I 2 comma 4 now will now be equals to 1 over 6 sine square sine cube x sine power 3 of x cos power 3 of x plus my I2 now, I2 comma 2 is 1 over 4 sine power 3 of x cos x plus 1 over 3 I2 comma 0, which is the last one we did, is what? 1 over 2 x minus 1 over 4. I use this 1 over 2 to open the bracket, sine 2x plus c. Finally, let me simplify it and show you the final answer. 2 comma 4 will just be 1 over 6 sine power 3 of x cos power 3 of x plus 1 over 4 sine 3 of x cos x plus, now this one will give me 1 over 6 because 3 times of x, this is 1 over 6 x minus, this is what? 1 over 12 sine what? 2x plus c. This is the given, this is the solution of the question, or solution to the question. Very simple. Just follow the reduction formula, you get your answer. Very simple. Now let me show one more. Let me show one other question. Let me show one other question. This one is the power. I gave you even power. What if I give you odd power of the function? Let's assume I turn it to 3 and 5. Example 2. Let's see. Let me show you example 2. Let's see example 2 for odd function. If you are example 2, integrate integral of sine 3x cos 5x dx. Still the same thing. Want to integrate this, just transform it to reduction formula. From my formula, it means the given function will be I of 3 comma 5, I of 3 comma 5, which is the same thing of saying, now if I apply the formula, I have 1 over, the sum of it is 8, I have sine 4x cos 4x plus, I'm going to subtract 1 from the end. I'm going to have 4 over 8, that is I of 3 comma 3. At the end of the day, I need to find my I comma 3. The next thing is to find I comma 3. How did I get this I comma 3? From the formula I m comma n minus 2. Then I comma 3. 3 comma 3 now, I want to apply the same formula. I have, this is 1 over 6 sine power 4 of x cos power 2 of x plus, I will come here again. 3 minus 1 is 2 over 6. 2 over 6 I 3 comma 1. 3 comma 1. 3 comma 1. And from here, I need to get I 3 comma 1. I 3 comma 1. If I transform I 3 comma 1 back to integration, this was an integral of sine 3x cos x dx. And if I apply my integration law, I know that this integration can also be written as integral sine 3x. If I differentiate cos, I'm going to have sine. I can have, if I differentiate cos, I'm going to have minus sine. Then I can easily say, if I put minus, I have d of minus sine x. It means I can put this to also be minus over minus. Then at the end of the day, this integration of this is going to give me minus 1 over 4 sine power 4x. Then substitute everything back to the given question and we have our result. Now it means my I of 3 comma 5 will just be equals to 1 over 8 sine 4x cos 4x plus 4 divided by 8 is 1 over 2. I 3 comma 3 is what? 1 over 6 sine 4x cos 2x plus 1 over 3. 2 divided by 6 is 1 over 3. And my I 3 comma 1 is what? Is minus 1 over 4 sine 4x. Now, if I simplify further, I will see that my I 3 comma 5 will just be 1 over 8 sine 4x cos 4x plus, I want to open the bracket, plus 1 over 12 sine power 4x cos square x minus, because plus or times minus is minus, I have 3 times 4 times 2. This is 1 over 24 sine 4 power x. This is the function. This is the solution. It means my integral of what? Of sine 3x cos 5x dx is equals to 1 over 8 sine 4x cos 4x plus 1 over 12 sine 4x cos 2x minus 1 over 24 sine 4x. That is the solution. You can simplify further if you like. You can take this cos to 1 cos square x to 1 minus sine square x. The same thing to this cos 4x. No, you can also do that. I think that is the solution to the question. Let us practice more questions. From there, we are going to be very good with reduction of formula. In our next class, we are going to look at Wallis formula. Wallis formula is just an application of reduction formula. This reduction formula is applicable only to integration with indefinite integral. When we have indefinite integral, that is, if the integration does not have upper and lower bound, that is where we use reduction formula. But what if it has upper and lower bound, that is definite integral? Then we are going to apply what is called Wallis formula. The next thing we are going to do is Wallis formula.